Hi.
Hi, I am so sorry.
That's fine.
So some of my upperclassmen are moving, and so
Yeah.
they were like selling their old furniture and stuff.
Yeah.
I ended up buying one of her TV and her TV stand, and then
You
she was like, "Can you please come right now?" I was like, "Right now?" So, yeah,
you bought an entire TV?
yeah. So like, I have a TV in my room now.
Wow.
I know it's kind of lopsided because it's over my carpet, but whatever.
Wow, that's kind of cool. I always
Yeah.
wanted a TV in my room.
Well, I mean, I now have two TVs, one in the living room, one in my room. But yeah, I'm just gonna have to
Wow.
put it up later. But right now, I'm just like, I can't. I'm so tired. So I just had my friend come and then help me. All right, Ritvik. So sorry.
No, 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 that's fine.
Um, what were you able to do?
So the 2016 International FRQ, our teacher gave that to us as a test this week.
Hmm.
Um, so I actually did it. I had to do it all in an hour and a half because like that's how long our class period was. So I was able to finish everything. But I didn't have any time left over to check. But that means like if I do get those like extra 15, 20 minutes in the real test, I'll have them to like check over my answers. So
Yeah, for
I think that
sure.
was good.
Okay.
And then I started 2015. Like I already did 2015 before, but I'm redoing the old ones like you said to do. Um, yeah.
What about the 99
Oh no,
EQ?
was I supposed to do that too?
No, I'm just wondering if you did it.
Oh no, no. I didn't.
Okay,
Sorry.
that's okay. No, no, no. I never specified to do this one. Um, so do you have homework that you want to go over or no?
Yeah, I have 2017. I also did a couple of Olympiads, and I was wondering if we could maybe take a look at some of the questions on those.
Okay. Oh, because you have to take the
Yeah,
test. Okay. Do you want me to
yeah.
the Olympiad right now?
Can we start with FRQ, the 20 the 2016 international? Because I did do it, but like I just want to make sure like I did it right.
2016 International
Yeah.
FRQ.
Yep.
What about what about I'm thinking what about the multiple choice of 2016? Have you been able to do that?
No, I didn't see a 2016 multiple choice.
Okay. No, I'm just wondering if you did it at school.
Oh, maybe then. Maybe. I'm not sure because it didn't say the year at the top. But like for this one, I was reading it over and I was like, these questions look kind of familiar. And then I looked at the international and I was like, oh, it's the same thing. So,
Okay. So I'm just gonna post it.
okay.
Um just post it. Yeah, and then we can go over them too.
Okay.
But this one is what you need.
Yep.
Do you have answers for them or
Yeah, yeah.
okay.
Okay. For one, A1, I got 21,900 joules.
Good.
Two, I got 19.3 grams.
Yes.
Okay. B1, I got negative 113 joules per Kelvin mole reaction.
Good. Good. Good.
Um, B2, I got negative 22.7 kilojoules for delta G. And then I said the reaction is thermodynamically favorable because delta G is negative.
Okay. So delta G is negative 22.7 kilojoules per molar reaction.
No reaction, yeah.
Yeah.
Okay, do I need to put the mole reaction part always, or like, would I get points off if I just put kilojoules per mole?
Um, per mole, per mole is fine.
Okay. Okay.
Actually, no, per mole reaction, just because, do you see how they've specified it here?
Yeah.
So yeah, you should.
Okay. Okay. And then for C, I got 5.3 times 10 to the negative sixth for KSP.
5.3 times 10 to the negative 6. Good.
For D, I said 15 milliliters of 1.0 molar HCl would increase most significantly, solubility most significantly, because HCl is a strong acid that forms H plus. So the addition of H plus will decrease the concentration of OH minus. And according to Le Chatelier's principle, a decrease in a concentration of product drives the reaction towards product. So adding HCl would drive the reaction towards products and increase molar solubility.
I think the last sentence you can omit it.
Okay.
Yeah. But good.
So
Otherwise,
I don't need to say that adding HCl would drive reactions towards products.
yeah, that's all you have to say.
Okay.
I think you always go one extra step.
Yeah, I just wanted to like make sure like I tied everything back together.
Yeah, but that's okay. This is not English class. So
Okay.
yeah.
For 2A, I got no because the oxidation number of carbon in all containing carbon species and all carbon containing species is +4.
Yeah.
B, I got 0.0188 moles of sodium bicarbonate.
Good.
C, I got 86.5%.
Good.
D, I said the mass percent of sodium bicarbonate would decrease because spilling some mixture would result in less sodium bicarbonate being heated and thus less water being formed. So a smaller calculated mass of NaHCO3 will be obtained. The mass of the original mixture would stay the same since you didn't reweigh it, but the calculated mass of NaHCO3 decreases, so its calculated mass percent decreases.
Yes. So you could have made that a little bit shorter, but
Mm-hmm.
calculated mass percentage would be smaller than the actual value.
Mm-hmm.
Because less water collected means
Okay.
less sodium bicarbonate in the sample.
Okay. Yeah, I think this is my shortest response that I've ever wrote for.
Okay.
Yeah. So calculated mass percent would decrease. So water or it would decrease because you're making less water.
Yes.
Okay. For E, I got 0.0045 molarities, E1.
Good.
KB, I got concentration OH minus times concentration bicarbonate over concentration carbonate.
Okay.
And then I got 2.0 times 10 to the negative fourth for KB.
2.0 times 10 to the negative 4. Good.
And then for F, SR2 plus CO3 2 minus yields SrCO3.
Okay. Good.
For 3A1, I got 0.809 moles.
0.809 moles of BF4 minus, yeah.
Yeah. Okay. For 2, I got 72.5 liters.
Yes.
Okay. And then for 3, I said the pH of the solution would decrease because H3O plus is a product. pH, then I like gave an explanation of like the pH formula and said that since concentration of H3O plus increases, negative log of concentration H3O plus decreases, so pH decreases. And then I said even though a base is produced in the reaction, it's the conjugate base of a strong acid, and it won't produce appreciable amounts of OH minus to neutralize the H3O plus formed. So there's still a net increase in H3O plus and net decrease in pH.
Okay, so you could have kind of omitted all that and
Okay,
you could have said the first sentence.
okay, that's it. Okay.
Yeah.
Um, so like when do I know that I need to like address the um that like there's a conjugate base being formed? Or do I just like never have to?
I don't think you really have to because
Okay.
they're just asking you straight up like, why is it more acidic?
Okay.
Yeah. So
Okay.
it's more acidic because you have more H pluses, which means more H pluses, lower pH.
Okay. For B, I got 1.0 times 10 to the negative fourth. Or 1.2 times 10 to the negative fourth.
Yeah. And what were the units?
Molarities per minute.
Okay.
Um, for C, I said I agreed.
I don't know why I wrote it there, but yeah. Yeah.
Yeah, for C, I said I agree because there's initially no products formed. So the concentrations of the products are both zero. The rate law of the reverse reaction is the reverse constant times the concentration of each product. So which means like if the concentrations of either products is zero, the reverse rate is zero. And since the concentration of both products are initially zero, the initial reverse rate is zero.
Yes.
Okay. For D, I got 0.4, 1 over molarity, or 1 over minute molarities.
0.41 over minutes molarity. Good.
And in that case, it said to calculate the value, but it didn't say units. So should I still always include units?
Say that again, the last part.
So should I always include units? Because in this case, it was only asking for the value.
Units, yeah, you do have to do the units.
Okay. Okay. For 4A, I said substitutional alloy. And then like I drew 9 gold particles and 3 palladium particles.
So it'll look like this, and then it'll have this, this, and maybe that, right?
Yep, that's what I did.
Okay.
For B, I said the E cell value is negative 0.16 volts, and the student's hypothesis is not correct.
Good. See, that was easy.
Yeah, that one was pretty fast. Wait, that one I wanted to clarify something. So like the student was basically saying there that the rhodium would replace the palladium for 4B.
So yeah, like basically, the reactions are not thermodynamically favorable.
Mhm. So yeah, I was a bit confused about the hypothesis itself, though. So he was like saying, or the student was saying that by placing the ring in like the rhodium solution, like the R3 plus, um, he said like they said that it would deposit onto the ring. But does that mean like it would replace the palladium?
Basically,
Okay.
yeah. But okay, number one, it won't replace it. Number two, this is not thermodynamically favorable.
Okay.
Because of that, it won't do that type of reaction.
Okay. Okay. And then for A, I put K plus is 1s2, 2s2, 2p6, 3s2, 3p6.
Good. Or you know that you can also do this, right?
Really?
Yeah. Unless they
Oh,
tell you like do the extended form, you can actually do it like that.
okay. Okay. For B, I said the first ionization energy of K is less than sodium's because potassium is bigger than sodium. So its valence shell is farther away from the nucleus than Na's. So there's less attraction between K's nucleus and its valence electron than there is between Na's nucleus and its valence electron. So it's
Good.
easier to pull off. Yeah.
Okay,
Okay.
so delete the last sentence. So it's easier to pull off, delete that.
Okay.
That's just redundant.
Okay. Okay. Um, for C1, I got 4.7 times 10 to the negative 19th joules.
Good.
And then for 2, I said no, because it only has 4.7 times 10 to the negative 19th joules, and you need 6.96 times 10 to the negative 19th joules.
Yes.
Okay. Six was also very short. Um, no, I forgot the lone pairs on the double bonded oxygen.
Tirori.
Okay.
Yeah, you want to make sure you have the lone pairs.
Yeah. Okay. For B, I said sp2.
Yes.
For C1, I said LDF and then dipole dipole, and then I said specifically hydrogen bonds.
Good.
And then for C2, I said LDF.
Good.
Okay. For 7A, I got 37.5 milliliters. For A, I got 37.5 milliliters.
Yeah.
Okay. For B, my first step was measure out 37 milliliters of the 0.4 molarity copper sulfate using the Buret. Place it in the 100 milliliter volumetric flask, and add distilled water to the 100 milliliter mark.
Good. So you would dispense 37.5 milliliters of copper sulfate using a Buret, right?
Okay, okay, good. Yep.
Yeah. And then fill it up with water to the mark.
Yeah. I didn't like specifically say like dispense though. I just said you measure it out and then you put it in the flask.
Yeah, you can do that too.
Okay. Okay. And then for C, I got 700 nanometers.
Okay. 700 nanometers. Yep, somewhere around there.
Okay.
Yeah. Okay. Um,
So I got at least 2 points off.
you got what?
At least 2 points off on this one then. At least two.
Oh, because you had that one unit one and then the lone pair one.
Lone pair. Yeah.
Let me
Can you
see.
give me more?
The lone pair one was 1 point, and then the
Yeah.
units.
Was also 1 point.
I'm looking. It was question number 2, right? No, it was question 1.
Yeah.
That was 2. That was 1 point because you got the thermodynamic stuff correct, but then
But
the units were wrong. So yeah, that was just 1 point. So you got 2 points off. Let me see the rubric. So here, question number 1, you got 9.
yeah.
Okay, let's see. You got 9, 10, 10, 10, 10,
A 4 for 5.
4.
Oh, and same for 4, I think. For
What
4
was
and 5, I
wrong with
only.
number 4?
Yeah.
What was wrong with number 4?
Because it's only out of 4.
Oh, these are 4. Just one second. Dude, you know you're going to get a 5.
I hope so. I hope I don't like choke in the moment.
You won't. The only problem is that we just want you to become faster.
Faster. Yeah.
Yeah. So you got a 47.82 for
Mhm.
Q. And then
Um,
multiple choice, we can figure it out. But do you see how you're already like close to a 5 just from the FRQ?
yeah.
As long as you don't mess up MCQ.
Um, yeah, fingers crossed. I think for this one, I got a 49 out of on the multiple choice that we took for this one. I don't know if it was 2016's multiple choice, but I
You
got
got
a
a 49?
yeah.
Ritvik, what are you worried about?
Uh,
I don't even
that
have to do math here. Okay, you're gonna get a 5. My only concern is we just want to be in the 80s, in the mid to high 80s, just to make sure that you're
yeah.
5s. Just because the rubric changes, like the chart changes a little bit, it
Yeah.
fluctuates every year. So,
Okay.
but you're fine.
Okay. Yeah. Thank you so
Boy,
much again for teaching me
stop it.
chemistry.
Okay. So which one do you want to do? The Olympiad?
Yeah.
Okay. I just have to get the Olympiad. Olympiad questions.
I'm already on my 4th notebook, or I'm about to be on my 5th.
Yeah, that's gonna be something that will continue throughout your life. My friends are graduating tomorrow, and then one of my friends was like, Maggie, it feels so weird to say that I am no longer a student.
Yeah, I just realized how close I am to graduating, and I felt really old.
Stop it. The only thing is you're still a student though.
Yeah.
You'll be fine. You'll be perfectly fine. All right.
Oh,
So what year were you looking at?
2014. And also, you know the person who I was telling you about who like got 0.1% error on her titrations?
Yeah.
Yeah, she's going to MIT, so it makes sense.
Of course. Wait, I don't know why this is not letting me download.
This
Okay,
one,
hold on.
Yeah, I did the national exam for 2014.
Oh, the bottom one?
Yes.
Part
Yeah,
three?
yeah.
Okay. I don't know what it is, but it's not letting me. The page is unresponsive, is what it's saying. Okay, Columbia. It's not letting me click on anything.
Hmm. Let me see if
Can you send it to me via chat? It's
yeah, like the website.
it's unresponsive.
The exams page is
Okay.
the exact same thing is happening for me. It looks like. I have the exams downloaded. Should I just email them to you?
Can you send it to me via chat?
The page is unresponsive for. Oh wait, it's up now. Let me send it.
I just chatted you.
Yep. Yeah. Because like it wasn't working for me either, but I have the exams already downloaded. So
What do
I
you
was
do?
thinking I could send them to you through email if that doesn't work.
Or just send it to me via chat.
Oh, I can put files in the chat.
Yep.
Oh, whoa.
You're supposed to be the young one here. Come on. Early it.
Wow. They didn't have this kind of technology back in my day. So
Oh, I see. Well, get with the program. In my day.
whoa, this is so cool.
Nice.
Wow.
Yeah, it's not letting me. It's not letting me download anything.
Okay. Here, I just sent them through the chat.
Okay, I got it.
Wow. Okay. Wait, so if your seniors are graduating now, what do they do like for the months before residency? Are they just like free?
Technically, so basically they get April, May, and June off because um they have to they have to get their CPR renewed. They have to move wherever it is that they need to move. Um, they also have to uh, apply for their licensing. So whatever state that they go to, they have to go through the state professional
License?
licensing department or something like that.
Yeah.
Where they have to like put in their paperwork and get all that. So apparently all that takes like a couple months.
Okay. Okay.
Yeah. And that's why like a lot of these schools, like a lot of the professional schools, like they are done with school like this early so that the students are able to get their paperwork in and whatever it is that they need to get in.
That makes sense.
Yeah. Yeah, but so one of my friends, like she actually is going to start working starting um end of April,
Yeah.
but because she doesn't have her license yet, because it takes time for the license to come in, um, she is because like after graduation, it takes about 2 weeks for the diploma to come in.
Yeah.
That's assuming that you can go and pick it up at school. Otherwise,
Okay.
it takes like a month for it to be like mailed to you.
Okay.
You need your diploma, and then you need like your transcripts and letters of rec because of the ethics committee, um, like the school letter of rec. Like I think it's just like a already pre-written letter that every student gets, unless this particular student is really, really not ethically there. Um, and then they get, and then you pile up all that, right? And then your
Yeah.
immunizations, and then your, HIPAA training, your CPR training, all that. And then you turn it in, and then the State Department processes it. It takes a couple of months, or I mean, couple weeks, to a few weeks, maybe a month or something like that. They were saying like, because we're in Utah, like the Utah department is like really fast, but a lot of the other states they're not as fast. So
Oh.
who knew that all this was something that they had to do? And like
Yeah.
the licensing exam that you took, right? Your board exam, your state licensing exam, the written part, the non-written part, the mannequin part, all that, like that's separate paperwork for all of these exams. So you need to get that all squared away and then turn it in.
Oh, so that's like boards, like
Huh?
that. So that's like boards, like all the licensing stuff is like board exams.
So, so board exam is basically the nation saying that this person is able to practice dentistry.
Okay.
Listen. So for med school, it's part one, part two. So that just means that you have the knowledge to practice medicine.
Okay.
You have the state licensing exam. So every state is going to be making you take another exam. And this exam is basically saying that you can practice at their state.
Okay.
So,
Okay. When are your boards then? They're in April, right? Or
so um, technically, pre-COVID, a lot of people were planning on taking boards in the spring. So pretty much right now,
yeah.
like March, April, May. But then with COVID and not having enough like test centers being open, a lot of us are actually taking it in June, July, August, September. Um, so I'm taking mine at the end of July, so which is a little late because if I'm applying to residency, a lot of these residency programs they want my scores to be out before I apply, which is in May.
Yeah.
But because this is COVID times, and even the DATs, which is like the SATs for dental school, have been canceled and been postponed, and it's just been a shit show. Um, what is it like? They're excusing us from not having our boards passed
Yeah.
before we apply to residency. It's no longer a requirement. But there's another exam that I have to take, which is called the ADA, which is the Advanced Dental Admissions Test. So this is kind of like the SATs, but like a higher level SAT, right?
Mm-hmm.
For residency. So it's like I have to take that. So I'm trying to take that in June so that by mid-July when my application is completed, because this is all like same thing with medical school applications, they open early June, and
Mm-hmm.
it's first come first serve basis.
Oh, yikes.
So the first person who gets their application completed, they are being looked at by medical schools, and then the medical school will decide if they want to invite you for an interview or not. And that's first batch, that's June. And then second batch would be like July. Third batch which would be like end of July, and then it keeps going. So by that point, like you would have people in front of you who already got interviews, who have already kind of made a good impression at the school or the program. And so when that happens, the more people are in front of you, it means that less chance of you getting accepted.
Okay. So you always want to apply early.
You always want to make sure you have everything ready to go by the time application opens. But that's
Wow.
for medical school. For college, it's different. College, there's a deadline, and admissions offices are not going to be looking at it until after the deadline. Yeah.
Yeah, that makes sense.
It's a little crazy, huh?
Yeah.
Because they just want to know, like medical schools and residency programs, they know that whoever is on top of it are the people that they want. So punctuality, being proactive, all that takes under consideration, which is kind of crazy, do you think?
Oh, yeah. So you have to like apply for medical school in your junior year of college.
If you want to go straight. Now, I would say like a good 75% of the students don't go straight to medical school from college.
Okay.
Just because a lot of these medical schools want students who have a bit more experience, life experience. So,
Hmm.
with that being said, a lot of students after college they do like a 1 or 2 year master's program.
Yeah.
A lot of students do like master's in public health or like master's in business or like me, like master's in biomedical sciences, things like that to just kind of like show medical schools like, hey, I am academically capable of taking graduate level courses. Because undergrad courses is one thing, but if you're able to do well on a graduate level course, it means that you are ready for medical school. It's kind of like taking AP in high school, but taking it
Yeah.
in college for grad school.
Okay.
Yeah. So even if you got like A's and B's in college, nowadays it's just not good enough, if you know what I mean.
Okay. Yeah.
And especially for medical school, they want to see if you've done research. So, on top of your school work, they want to see research, which is basically another science course on top of your science courses, which
Wow.
does take up a lot of time, or at least it did for me.
Yikes. This sounds very stressful.
Yeah, that's okay. Okay, which number?
Okay. The first one I was confused about was um well, actually number 6, but could you just go over what osmotic pressure is?
Yes, so osmotic pressure is basically like this is the osmotic pressure um, formula. It's
Hmm.
ions, molarity of the solute, R, which is gas constant, and temperature.
Okay. What value of R is it?
R, I believe it is the gas constant, which is 0.0821.
Oh, okay. Yeah. I did. Yeah. Because like I know there's more than one value for different units.
Oh, so the 8.314 is for energy.
Okay. 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 So this one is your okay. Okay. Um, so would number 6 not have been PV equals nRT then? Or because that's what I used.
Number two,
Number 6, number 6.
it's not PV equals nRT. Is that what you're saying?
Yeah, because I used PV equals nRT and I got the right answer, but I wasn't sure if it was just a fluke or like if it was like actually the right answer. I just plugged in the osmotic pressure for P and PV equals nRT and solved for molar mass.
Yeah, that's fine.
Okay. Okay.
Because osmotic pressure at the end of the day, it's pressure.
Okay.
Yeah.
Um, Number 11, I was also slightly confused on.
When you do primary standard, you want you want a weak acid base.
Okay.
because if you want to standardize it, it needs to be slow enough for you to be able to calculate things. But if you add a very
Okay.
strong acid or base, it'll just like shift everything towards one side.
Okay. So primary standards are weak acids and bases.
Yeah, because you're standardizing it.
Yeah. And they're used to standardize like strong acids and bases.
Yeah.
Okay. Um, the next one I was confused on was 21.
Lowest entropy.
Yeah.
Lowest entropy means that they are going to be solids.
Hmm.
Um, okay. Rule of thumb for organic chem.
Hmm.
If you have a single bond, it's going to be pretty much the most stable. Double or triple bonds, the pi bonds, they want to
Yeah.
go and react with something else.
Hmm.
So with that being said, butenes, they're all double bonds. So those double
Okay.
bonds are going to do an alkene reaction.
Okay.
Cyclobutane is actually a pretty stable thing.
Okay.
Um, so it actually looks like this on the side.
Oh.
So these are all hydrogens. So on
Yeah.
the side, it kind of looks like a chair. We call that chair conformation.
Confirmation. Okay.
So it looks like kind of like a lawn chair, so it's pretty stable.
Okay. Yeah, because I remember like cyclopropane isn't stable though, right? Because it's like super tight, or is that stable too?
Yes.
Okay.
So pentanes are pretty stable, but anything below that, like a butane, cyclobutane, or uh, cyclopropane, they're very unstable. We call that sterically hindered. It's like um, instead of like this,
Mm-hmm.
you're bending it.
Yeah.
Instead of like
Okay.
letting it stand on its own, you're bending it. And
Okay.
one day it'll snap off.
Okay. So cyclobutane then is not stable, or it is stable?
Cyclobutane is stable. So anything above 5 rings, it's pretty stable. Anything below that, not stable.
Okay. Doesn't butane have 4 carbons though? Or
Oh my god, why did I think this was cyclohexane? Um,
the
cyclo-
answer was D. I was just confused about why.
oh, I totally misread this. I was thinking cyclohexanes. Hold on, let me see. Okay, yeah. It's because this is gonna go and do a reaction, this is gonna go do a reaction, this is going to do a reaction. This one is not. There's no reaction.
Okay. So cyclobutane doesn't really react, it just breaks.
Yeah.
Okay.
But even the sterically hindered part it's still kind of better than having
Yeah.
free-ended pi bond that can go and react with something.
Okay. So sterically hindered, um, but still better than double bonds.
Uh-huh. Especially number one, because one butene, so readily available to go and do some type of chemical reaction.
Okay, okay. Okay. Number 24, I was also a little bit confused. Um, so I got the right answer, but the way that I did it was multiply like the 8.314 gas constant by the temperature, and then multiply that by the moles of nitrogen produced. But my friend had a different way. He like actually calculated work using P delta V, and then like he did some conversion factor using a gas constant.
Yeah, you can do that, but how much work is done by the gas from 1 gram of sodium? It compounds in a container changeable volume. Yeah, how did you do it again?
I just multiplied the 8.314 gas constant, 8.314 joules per mole Kelvin, times the temperature in Kelvin, and then I multiplied that by the number of moles of nitrogen that formed, and I got B. So
Did he get the same answer?
yeah, I just wasn't sure like if my way worked.
Yeah, your way works. You can do it with
Okay.
equals nRT, yeah.
Okay.
Yeah, your way works. You can do it with, so PV equals nRT, right? That's what you did?
No, I just canceled out units. Like, I saw
Just
that
canceled out the units.
yeah, I saw the units for the gas constant were joules per mole Kelvin. So I multiplied it by moles in Kelvin and I got joules. So, but is that like a shorthand for PV equals nRT?
Uh, Hold on. Equals nRT changeable volume. Yeah, you could do it your way.
Okay.
Technically, what your friend did is the right way of doing it.
Yeah.
Yeah, you're fine.
Okay.
Yeah,
So when work is done by something, it has a positive value, but when it's done on something, it has a
it
negative
has
value.
negative. Yeah.
Um, 28 then, I was confused about.
If temperatures increase, molecules are going to be more likely to collide and they're going to reach product faster.
Yeah. So the both rates increase.
But do you see how like the entropy change are equal to each other?
Yeah.
So that activation energy is exactly the same.
Oh, oh, okay.
So I don't think anything will change. They will increase at
Okay, okay.
same
So if the
rate.
activation energy of two reactions is the same, their rates are going to increase by the same amount.
Yeah.
Okay.
I mean they have to.
Okay. Yeah, because the reason I was confused was I thought that C to D was exothermic, so the reverse reaction would increase more than the forward reaction.
But exothermic, endothermic is delta H. It's not
Yeah.
entropy.
Isn't this, does that
But
say
the
ent
graph is entropy. And they're asking about rate, which is different.
Oh,
Because rate is more like entropy because the more chaotic they are, more likely
uh-huh.
for them to overcome the activation energy.
Okay.
Does that make sense?
Yeah. Wait, so is energy the same thing as entropy then on this graph?
Energy is not the same, but you can associate the two,
With okay. Okay.
yeah, together because, yeah, one was able to overcome the activation energy better.
Got it. So this isn't like this isn't a delta H versus time plot like where you have the activation energy in the complex, right?
Yeah, no.
Okay. Okay, that makes sense. So if the entropies and their so if the entropies and activation energies are the same, then you have the same increase in rate.
Mhm.
Okay. Um, okay. I was a little bit confused on 39. So to me, it looked like the reaction at the top, in the reaction at the top, both copper and I minus were being oxidized. But I was kind of confused about that.
I minus is getting reduced. So you have to flip the reduction potential. You have to flip this.
Yeah. How do we know that it's getting reduced though? Like from
Because
the
it's
top?
going from here to there, and this is going from there to there.
Yeah. But is I minus to I2 oxidation? Like there's a little thing with platinum at the end too, so that's what like threw me off. Like there's PT right after the line.
Um, so that's anode, and cathode, anode, oxidation, excusing. So hold on. This is
Or
anode. This is
mhm.
cathode. Means you flip this and you flip that.
Yeah. How do we know I minus is the cathode though? Because they didn't specify that it's galvanic. They just said, or is electrochemical the same thing as galvanic?
No, electrochemical is the whole thing, but you can assume that this is galvanic based on the line equation, because convention is you always start with anode, double line, which is the
Got
salt
it.
rich, and then cathode.
Okay.
Yeah.
Okay.
So copper is getting reduced. Sorry, copper is getting oxidized. Iodine is getting reduced, and then you add the two numbers.
Got it. So you start with anode half equation in the line representation.
Yeah.
So what's the little thing with like PT at the end?
That is just a catalyst.
Okay.
Yeah, that's usually just a catalyst that's just there to help out, or like a phase binding. I don't know, not phase binding, but yeah, it's usually a catalyst.
Okay.
Yeah, this is the line notation.
Okay. Okay, let me just write that down. And then the double line signifies that like you're switching reactions, right?
Yeah,
Okay.
not switching reactions, but the salt bridge.
Oh, okay.
Yeah,
Okay.
it's the salt bridge.
Oh, okay. And then 43. Yep.
Oh, these you just have to memorize.
Okay.
I don't know because I never memorized it.
Okay.
Hold on a second. Now I'm curious. So apparently it's got four nodes.
Mm-hmm.
Okay, hold on. Let me educate us. So oh,
Oh.
so this is what they're saying. Okay, hold on a second. I think there is a list. So it's like it's four nodes because it's 5 - 1 = 4, and there are two angular nodes.
Mm-hmm.
Um,
So angular nodes is L minus 1, or is it just L? Since there's two.
angular node is L. Radial node is n minus L minus 1.
Okay. Okay. Okay, that makes sense.
Angular node is just L. Radial node is n minus L minus 1.
And then this is for all orbitals, right?
Yeah.
Not okay. Okay. Okay, yeah. I think I get it. Um,
Yeah.
and you can calculate n based on the number of radial nodes, right? Like the shell number. Like what? Okay. Um, okay. 58 was the last one on this test.
Harder for polyacetylene is unusual for organic polymer. I don't know. This one, I think you would just have to. I don't know what polyacetylene looks like.
Yeah, I didn't know what it was.
Oh, it conducts electricity.
Oh, okay. So most organic compounds don't conduct electricity.
Organic compounds do not conduct electricity, but polyacetylene is a semiconductor apparently.
Yeah.
Um, where is it used? Usually, yeah, carbon molecules don't conduct electricity, but it says highly conductive materials, polyacetylene.
Okay. Yep, that was everything for this one.
That sucks that you guys just have to like memorize random trivia. Like,
Yeah. Would this one have been doable by process of elimination though? Like, because like I was thinking that there are definitely polymers that have high boiling points and that are strong.
yeah, those are very strong. Bless you.
Thank you.
You
So
know, like Ferrari and Lamborghinis, they're
yeah.
made out of metal, right? The car itself.
Yeah.
They're made out of carbon fiber. You know that,
Oh,
right?
carbon?
Yeah, they're made out of carbon fiber, and that's why it's so expensive because it's bulletproof.
Ferraris are bulletproof?
Yeah.
Wow.
So you know how they say like some of these cars are bulletproof? That's what they mean when they say they're bulletproof.
That their car. Oh yeah. Yeah. Wait, wow.
Does that make sense?
Yeah.
It's a little crazy.
So organic compounds are strong, polymers are strong.
Yeah, like vinyl, that's like
Yeah.
plastic.
Oh yeah, okay.
Plastic is strong. I mean, it's strong, but it's also brittle when it's hard,
Okay.
right?
Yeah. So it's like okay. Yeah. That makes sense.
So, okay. Which other one do you need?
2015. I also sent that one in the chat.
Are these harder than the ones that you were doing, the local ones?
Um, I think it sort of depends on the section. I feel like some like I know that there are like really hard ones on the math ones on the local section, but I'm not seeing those. It looks like in general though, like some of the content-based ones are like harder or more obscure. So yeah. But that makes sense because they have to choose like 200 kids to go on to the next round from,
Yeah, for sure.
yeah. So,
Crazy.
you know, okay, let's see. I wanted to make sure something about aluminum. So there's nothing that aluminum is like, there's no like special rule where aluminum is like insoluble with compounds, right? It's only like, yeah. So like aluminum is almost always soluble unless it's like with one of those insoluble exceptions, right?
I think so.
Okay.
Yeah.
And then sulfate is always soluble or like is almost always soluble, but sulfide is almost never soluble.
You mean SO42 minus?
Yeah.
No. SO42 minus is insoluble when it pairs up with Bacasser. Remember? Sir Baka, barium, calcium, strontium?
Yeah.
They're completely insoluble.
Okay.
And AP history, they're completely insoluble. Sulfides, I think you're confusing with sulfates with being strong acids. If they're strong acids, then they are completely soluble.
Yeah. Okay. And then
Fine.
sulfides are weak acids, so they're not
Okay.
okay.
Yeah.
Okay. Um then the first one was number 11. Oh wait, sorry. I had a question about 2014 that I just remembered. Number 48, I just realized I was a bit confused on 2014. Sorry.
The radii.
Yeah.
What about it?
Yeah, I was confused between C and D for that one.
Um,
Actually, between like B, C, and D for that one.
okay. Well, D, for instance, that's based on the valence shells, right?
Yeah.
But then Fe2 plus versus Fe3 plus, it's a little bit different because Fe2 plus, I believe, you are, where are, let me find a periodic table. Well, actually, we have a periodic table up here, huh? Fe2 plus 1, 2. Okay, Fe2 plus 3 plus, it's not going to make a huge difference. It's just that 3 plus is going to be a little bit smaller. And then Na and Mg, you know that Na and Mg are going to be pretty big of a difference
Yeah.
because sodium has 11 protons, magnesium has 12. So magnesium will be smaller because everything wants to be pulled in because of effective nuclear charge.
Yeah. So it has a much bigger effective nuclear charge.
Mm.
Magnesium.
Yeah, and then manganese and iron. Where the heck are they? Okay. So manganese and iron, we're looking at valence electrons. So they are in the 4s2. So they both have the same number of valence shell. They have the same number of shells. And then
Mhm.
yes, iron is going to have a little bit more protons, but because of shielding effect, it's going to be feeling a little less pull towards the protons than sodium and Mg because it's technically the same thing.
Yeah.
Technically the same thing because
Mhm.
this one has three and this one has four shells, right? But it's
Yeah.
of just one proton between the two sets. But manganese and iron, they have one extra shell, so they have a shielding effect happening, which means
Okay.
they're going to be closer than they are.
Got it. Okay.
This is going to be less than
Okay.
human magnesium.
So the reason for that difference is because the difference in electrons in iron and manganese is like in an internal shell, and for the others, it's an external shell or a valence shell.
Yes, but when we're talking about effective nuclear charge, we're talking about proton numbers.
Got it. Okay.
So proton numbers, yes, is a difference of one proton,
Hmm.
but we have shielding effect. So
Shielding effect.
four
Okay.
shields versus three shields.
Oh, okay. Okay. So it has, so, okay. So there's more of a shielding effect in that. So they're more similar. Okay. Okay. That makes sense. Then why is it not Fe3 plus and Fe2 plus? Is that because like bigger difference in shielding effect?
This is this is because bigger difference in nuclear charge.
Okay. Okay.
Because it's the same exact atom.
Okay. Oh, yeah. Okay. So the bigger the shielding effect of two atoms, the more similar they're going to be in size.
Yeah.
Okay. Okay. Yeah, sorry. That's really everything for 2014.
Okay. Okay, 2015.
Yep. Number 10 was the first one I was confused about, and that one.
There's no
The answer for this one was C.
C.
Yeah, because I think calcium fluoride makes a precipitate.
This is a precipitate.
Yeah, apparently. I remember getting this wrong on another Olympiad. So
Oh,
it's
I would have gotten it wrong too. Because I thought CIF2 was soluble.
yeah, so
Oops. I taught you wrong.
I mean it was right for the AP. So
No.
it just Olympiad is annoying.
Okay.
So CAF2 is white then?
Yeah.
Okay. Okay. The number 11, I got wrong. Or yeah, and I was confused.
Okay. Elemental silicon is oxidized. So silicone and carbon dioxide, no, not carbon dioxide, carbonate. Okay, when silicone is oxidized,
Hmm.
it means you're creating silicon dioxide. It's glass.
Okay.
So silicon dioxide would so silicon dioxide is sand, and then when
Yeah.
it gets dissolved with sodium bicarbonate, I believe that's how you make glass.
Okay. Wow. Okay.
So they want you to become a glass expert.
Yeah, I should have seen that coming. So when Si is oxidized, SiO2 is formed. Um, then when you dissolve it, dissolve it in molten Na2CO3, you make glass. And then wait, but do you need to put an HCl to make glass? I think that's the part that messed me up. Like when it's treated with HCl.
I guess.
Okay.
Yeah, I'm not 100% sure.
Okay. Okay, so glass is technically a precipitate then?
Yeah.
Okay. Number 16 then I was
Oh, this one. Yeah, because dioxygen and ozone are both gases.
Mhm.
Gray tin and white tin, they're both metals.
Yep.
So they are both, I guess, metals.
Okay.
Phosphorus and red phosphorus. I know one of them conducts electricity. I don't
Okay.
remember which one. Rhombic sulfur and monoclinic sulfur. What the freak? Sorry. You're like, Vicky, you should know this. Red phosphorus versus white phosphorus. Okay, so red phosphorus is network solid.
Got it. Okay.
White phosphorus is a crystal that is a natural combustible compound. White
Okay.
says that it is not stable in air.
Okay.
I don't know what this rhombic is. Rhombic sulfur.
The answer was B. Um, yeah, I was just confused about why. I didn't know that there were so many colors of phosphorus. I thought it was just green.
Okay. Rhombic and monoclinic are literally the same thing.
Okay.
It's just that one is more stable. Rhombic is more stable than monoclinic. And the
Okay.
shape is a little bit different. One's more needle shape and the other one's more round. That's it.
Okay.
Yeah, I just know that red versus white, one of them conducts electricity, and I'm assuming the red one is the one that conducts electricity.
Okay.
You'll learn this in physics.
Phosphorus? You learned about phosphorus in physics?
Phosphorus and silicon, because they conduct electricity. That's how we have. That's how like AC adapters work, and that's how like a lot of the computers work. That's
Wow.
called the Silicon Valley.
That makes sense. Wow.
I'm sorry, it makes no sense to me.
No,
I
I mean like yeah, I was always confused about Silicon Valley as a kid. I always thought it was like a valley with silicon, not like
yeah, me too. I'm still confused about that. Yeah.
yeah.
All right, what's next?
Let's see. 32. Wait, no. Sorry. Um 35. 35. Wait, sorry. Rhombic sulfur is more stable than monoclinic.
Yeah. According to Google.
Okay.
Oh, this is now.
Yeah. Um yeah. The way I thought to do this one was like to write out the KF expression and like the KSP and then combine them into one expression and then do an ice table. My answer was not on the sheet though. So
So, don't you have like a solution somewhere?
no, not for this one. There is no solution for these tests.
Okay. So this is a lot of math for one freaking question.
Okay.
But here, where is it? What number was it?
35.
Okay. So I have, I'm just gonna do it here. So we have KSP, AG, and then Cl minus. And then from here, Ag plus 2NH3 will yield AgNH3 2, right?
Yep.
Oh no, why is this not letting me?
I think it's because you have a text box up there.
Oh,
Like every time you type, it's like it enters in the text box and drags you up right there.
man. Okay, that's okay. So now KF is this.
Mm-hmm.
Okay.
Yeah.
Then AgCl, which is a solid, 2NH3, which is aqueous, becomes Cl minus, which is aqueous, plus AgNH3 2 plus, which is aqueous, right?
Okay. Okay. So you add them together?
You add them together because that's what you're doing, right?
Yeah.
Okay.
Yeah.
So now the new net equilibrium constant is going to be Ksp times Kf.
Okay. Okay. Yeah, I tried doing that.
So what was it? 1.
Um,
-10.
yeah, 1.00 times 10 to the eighth for Kf and 1.8 times 10 to the negative 10th for Ksp.
1.0 times 10 to the negative 8.
Yeah, 10 to the 8, not negative 8, just 8.
Okay. So if you add these up, it's 1.8 times 10 to the negative 2.
Yep. Yeah.
Okay. So if you do this, it's basically going to be Ag plus and Cl
Oh.
minus
Oh.
AgNH3 2 plus
Mm-hmm.
over Ag plus and NH3 2, right?
Yeah.
This and this cancels out.
Mm-hmm.
So you'll end up with Cl minus
And
over
plug in.
NH3 2, right?
Yeah.
So that's what you have. But now we have to also find the net reaction so that we can plug in the numbers. HCl, which is a solid, plus 2NH3, yield Cl minus, plus BgNH3 2, right? Oh, 2 plus, right?
Yeah.
So obviously we're not using this. This is negative 2.
And they give you they give you concentrations, right? Like you need 0.01 moles of AgCl. So can you plug that in for the concentration of Cl minus and of
Yeah.
NH3 plus?
So I don't know what this is, but these are zeros. Minus 2x plus x, right?
Uh-huh.
This is 0.01. This is x and this is minus 2x, right?
Yeah. Wait, sorry. So x is equal to 0.01 then, right?
Yeah,
Okay, okay.
which means this is 0.02, but this is like NH3 minus that.
Got it. Okay. So then you solve for initial.
So then, what did we say the answer? 1.8 times 10 to the negative 2. 1.8 times 10 to the negative 2 is equal to 0, 1 over NH3 minus 0.02 squared, right?
Yeah. Oh, and then you solve that. Okay.
Yeah. This is, I'm sorry, this is too much for one freaking question.
I know. I agree. Okay.
Okay. Does that make sense?
Yeah. It's really long, but yeah.
Well, I mean, now you know how to do it.
Yep.
Okay. All right. So, how many more questions do you have?
I have a few more, but we can go over them next time.
Is that
Uh,
okay?
yeah. I actually could we maybe move back our session 15, 20 minutes because the Olympiad exam is at 2 o'clock. So
For next week?
yeah, next week, Sunday at 2 o'clock.
So you want, what time do you want the class to be at?
Maybe just like if we could push back like 15 minutes to half an hour, just so that like I have more time for the like to like get ready before Olympiad or
Okay,
like
just one
just
second. When you say push, I'm really bad at English.
oh wait, push forward. Wait,
So you want it to be at 12:30?
no, earlier. Sorry, earlier. So like 12, 12. Sorry, I'm really bad at this.
At 12
Well,
o'clock?
yeah, 12 o'clock.
Um, okay. Just because I actually do have another student that ends at 12 o'clock. So
Okay.
hopefully if she lets me start early, I'll text you.
Okay.
Okay. Whenever I'm done with her, I'll text you. I'll ask her to
Okay.
move it up a little bit.
Okay. Sounds good. Thank
Sounds
you
good?
so much.
All right. Can you remind me the night before, like on
Yes.
Saturday?
Yeah.
Okay.
Saturday night. Okay.
Yeah, Saturday night, just send me a text and just be like, hey, can we start class a little bit early if possible, and I'll remember to ask my other.
Okay. Okay. Thank you so much.
Yeah, you're welcome. All right. Well, good job. I'm sorry about today.
No, no, no. It's fine. We got a lot done.
Sounds good. Okie dokies. I'll see you next week.
Bye.
Bye.